Hello everyone, my name is Difa Azwir. I'm here to explain the case number 1. From the case number 1, this is the information that we got from case number 1, the GF, the R, the G, and also the cash flow. We're gonna do the A first. For case 1, the formula is PF equals CF divided into R minus G. So we're gonna do the A1 for like the CF is 40,000. So 40,000 divided into R, which is this one. So minus G, which is this one, equals 40,000 divided into 14 minus 7, which is 7. And the result will be 570.428. So when the PV is 570.428, that means less from the initial investment, which is 650. So the business can start. Do the B1. So B1 is the company is somewhat unsure about the assumption of a 7% growth rate in its cash flow. At what constant growth rate would the company just break even if it still required a 40% return on investment? So PV equal initial investment so it's 4,000 equal divided into 0.14 minus G equal 650,000, and do it again, 0.14 minus G equal 40,000 divided into 650,000. So the G is equal into 0.0615. So the G is 0.014 minus 0.0615. So 0.07085, or it can be also 70.85%. So the company would do break even if the growth is 77.85 instead of 7%. Thank you, that's number 1.
Hello everyone, my name is Faiq Naufal Gunawan, and I'm going to explain to you guys how to finish case D, question A and B using Excel. The first thing you have to do is you have to insert all the information that is stated in the question. For example, like the annual quantity, also the variable cost, the fixed cost per year, the equipment cost, the salvage, the project life, the tax rate and discount rate, also the net working capital. The depreciation is count by minusing equipment costs with the salvage value and divided by the project life. And divided by the project life. It will get us $94,000. After that, how you actually found the bid price per carton when the discount rate is 16%. The first thing you have to do is you have to find the operating cash flow. Operating cash flow consists of counting a bid price times with the annual quantity minus the annual quantity times annual quantity minus annual quantity times variable cost minus fixed cost per year minus depreciation per year times times 1 minus tax rate plus the depreciation per year. Bear with me. Why this is minus? Because we haven't actually insert anything to the bid price per carton. So just bear with me first. The next one is to find the present value of operating cash flow for 5 years. How to do it is by count uh, operating cash flow times with present value. You just can type like present value of present value of this discount rate and per with the project life, also with -1. The next one is the present value of salvage plus the net working capital on the end of year 5. How to count it is just by adding the salvage value, with the net working capital, and divide it with 1 plus discount rate and dipangkatkan with how long is the project. And after you did this, you count the NVP, which is by minus equipment cost minus with the net working capital minus plus the PV, also added with the PV of salvage. So it's still minus because you haven't actually do anything to it yet. After you, how to find the bid price per carton when the NPF is 0 is by go to data menu, go to what if analysis, and go to goal seek. Go to data, go to what if, and go to goal seek, and set the value to 0 because we want to NPF to be 0 by changing cell 12. So the bid price per carton, we're going to change it to USD first. So the bid price per carton that we want on the return rate of 16% is $10.09. The next question is how to found the NPV at price 11. So we can actually change it to 11, and we already get the NPV of $330. That's all from me. Thank you.
Hello everyone, my name is Najla Nazhifah, so I will explain for the first two. First is year 0, is initial investment. The company spent $14 million to purchase equipment. They also allocate $1,500,000 for initial working. So total investment equal 14 million plus 1,500,000 equal $15,500,000. This is cash outflow show as negative. Net cash flow in year 0 is negative $15,500,000. Next is year 1, first year operation. Its unit sales 95,000. Selling price per unit is $330. Variable cost per unit is $210. And fixed cost $750, and the depreciation rate is 14.9%. For the revenue is 95,000 times 330. We got $31,350,000. And variable cost we got is 95,000 times 210. We got $19,950,000 is and next is depreciation. 14 million times 14.29%, we got 2,600,000. And for EBIT is revenue minus variable cost minus fixed cost and minus depreciation. We got $8,649,400. And next is tax. Tax is EBIT times 35%. 8,649,400 times 35%. We got $3,027,290. Next is net income. Net income is EBIT minus tax. We got $5,622,110. Next is operating cash flow. Operating cash flow is net income plus depreciation. We got $7,622,710. And for the additional working capital, sales increased from 95,000 to 107,000, equal growth of 12,000 units. Additional working capital is 12,000 times 330 times 20%. We got $792,000. The rest is net cash flow. Net cash flow we got from operating cash flow minus additional working capital. Got 7,622,710 minus 792,000. We get $6,830,710. Next is second year continued growth. Unit sales is 107,000. For the revenue is 107,000 times 330. We got $35,310,000. Next is variable cost. It's 107,000 times 210. We got $22,470,000. And depreciation is 14 million times 24.49%. We got $3,428,600. And EBIT is revenue minus variable cost minus fixed cost and minus depreciation. We got $8,661,400. Tax we got $3,031,490 from 35% of EBIT. Next is net income. We got net income from EBIT minus tax. We got $5,629,910. And next is operating cash flow. Operating cash flow is net income plus depreciation. We got $9,058,510. And additional working capital increase of 3,000 units. We got 3,000 times 330 times 20%, and we got $198,000. And last is net cash flow equal 9,058,510 minus 198,000. We got $8,860,510. Next is third year. The unit sale for third year is 110,000, and the revenue is 110,000 times 330, we got $36,300,000. And variable cost is 110,000 times 210 equal $23,100,000. Depreciation is 14 million times 17.449%. We got $2,448,600. And EBIT is revenue minus cost. We got $10,001,400. And tax is 35%. We got $3,500,490. Net income $6,500,910. And operating cash flow is net income plus depreciation. We got 8,949,510. Additional working capital is 2,000 times 330 times 20% equal $132,000. And last is net cash flow. Net cash flow we got from operating cash flow minus working capital. We got $8,117,510. Next is fourth year. The unit sales for fourth year is 112,000, and the revenue is 112,000 times 330. We got $36,960,000. Next is variable cost. We got $23,520,000, and the depreciation equal with 14 million times 12.49%. We got $1,748,600. And EBIT, we got $10,941,400. Next is tax is $3,829,490. Net income is $7,111,910. And operating cash flow we got from net income plus depreciation, we got $8,860,510. In the fourth year, for the additional working capital, we got 0. And last is net cash flow. Net cash flow in fourth year is same with operating cash flow is $8,860,510. The last is fifth year. The unit sales in fifth year is 85,000, and for the revenue is $28,050,000, and variable cost is $17,850,000, and the depreciation is 14 million times 8.93%, and we got $1,250,200. Next is EBIT. EBIT we got $8,199,800. Next is tax. Tax is we got $2,869,930. Next is net income. We got net income is $5,329,870. And operating cash flow There's net income plus depreciation. We got $6,580,070, and we got at salvage and recover working capital equal with 4,200,000 plus 1,500,000, and we got $5,700,000. And last is net income. Net income we got from operating cash flow plus recovery. We got $12,280,070. So we got the NPV, and so that's my explanation for phase 2.
Hello everyone, my name is Wasis Hasan, and I'm going to proceed to the C part of case number 3. Okay, so the question is solve problem A again with the price is still at $11, but find the quantity of cartoons per year that you can supply and still break even. Hint, it's less than 170,000. Okay, so let's define the cartoons per year by Q. Okay, so the first one is revenue. The revenue is 11Q. Okay. The second one is variable, which is 8Q. The third one is fixed costs. Which is $160,000. And the last one is depreciation. Depreciation, which is $1,102,000. Okay. So let's start with the EBIT. The EBIT is 11Q. Minus by 8Q minus by 160,000 minus again by 102,000 equals 3Q minus 262 the OCF. Right. The OCF is 3Q minus 162,000 times by 1 minus 0.35 times I mean, by 102 equals 3Q minus 3Q minus 262 times 0.65 142. Okay. Then we proceed to the NPV. The NPV minus 57,170,000 plus OCF times 3.2743 plus 37.610 equals 0. Then OCF times 3.2743 equals 522,000 and 390. Then OCF equals 150 90 50 and 9,400. Okay. Now we solve. Okay, let's create a new notes. So, okay, now we solve the 3Q minus 262 times 0.65 plus 102,000 equals 159,000 and 490 proceed to 3Q minus 262,000 times 0.65 equals 57,490. Proceed to 3Q minus 262,000 equals 57.490 0.65 equals 88,446. Proceed to 3Q equals 315.446 and Q is equals to 116 and 806 and 815. So you only need to supply 116,815 cartons per year at a price of $11 to break even. Let's proceed to the D part. Okay. The question is repeat C with a price of $11 and a quantity of $170, 170,000 cartons per year, and find the highest level of fixed costs you could afford and still break even. And it's more than $160. Okay. So, we now solve for the maximum fixed cost that allows NPV with we define the Q as $170, 170,000. The P is for $11, and the OCF need to break even from before, from 159 490. Okay. So the revenue is $1,870,000. The variable cost equals to $1,360,000. Okay, the EBIT is we minus these two, so 1,871 minus 1,360,000, and we minus F for the fixed cost minus 110, sorry, minus again 102 and 000 equals 265 and 200 minus 0.65 F plus 102 equals 3367 200 minus 0.65 F. Okay, so now we set the OCF to 159,490. So we conclude the 367 200 minus 0.65 F equals 159 490 0.65 F equals 207 7. Okay, so the F is 390 and 554. So at $11 per carton and 170,000 units per year, you can afford fixed costs up to 319 and 454 $1,000 per year and still break even. This is significantly more than $160,000, showing strong margin. Okay, thank you.
Hello everyone, my name is Jourast Armund, and next we are going to discuss case study number 4. So in this case, Hilgila Golf has decided to launch their new line of golf clubs. That this is the description of the product. They will sell 600 per set, and their variable cost will be 240, and the expected annual sales that their marketing study determined is 50,000 sets. But they have 2 other product lines before. The first one is high-end club. So they predicted if they or they wanna sell less this product. So the unit loss for the high end is 12,000, with the price that they sell is 1,000, and their variable cost to make is 550. And the second line that they already have is the cheap clubs. So they plan to sell more 10,000 clubs, or the cheap one, with the price of 300, and also with the variable cost of 100. Then this is the other data given by the question. For example, this one is fixed cost per year, 7 mil. Plan, we have plan and equipment, which mean one-time cost to start the production, and depreciation. The way to calculate this is the plan and equipment divided by 7 years, because here they wanted to do the project for 7 years. This one, right? And network working capital, which is extra money needed to run the project, 900,000. Marketing study 150,000. Research and development 1 mil. And there, with the tax rate of 40% and the cost capital of 15%, 14%. Also. This one is 14%. The first one, we want to calculate the annual cash flow. So for this, we calculate one by one. The new clubs, the revenue is, we can just calculate it by the price times the expected annual sales. So 600 times 50,000. So the revenue is 30 mil. And for the variable cost, the same. You times the variable cost with the expected annual sales. So 240 times 50,000 is 12 mil. And we do the same with the rest revenue for high end. So they say they wanna decrease their sales on high end with the amount of 1,000. So 1,000 with the amount of 12,000. So this is the price that they sell. So 1,000 times 12. Same with this. This is the variable cost times the expected product loss. Also, it's the same with the cheap one. 300 is the price that they sell, and then this is the expected surplus. What do you say? Additional units. So 10,000. So 300 times 10,000. Same with the variable cost, 100 times 10,000. And for the total incremental revenue, or the total incremental revenue, we just add all the equation, 30 minus 12, because why minus? Because this one we wanna this is the unit loss of high end, so that's why we put minus here, minus 12 and plus 3 million, which is 21 million. And the total variable cost, the same. We add all the variable costs from this. We get total 6.4. Now we gonna calculate the gross profit, which is revenue minus variable cost. 21 mil minus 6.4. So the gross profit is 14.6. Next steps, we wanna calculate the EBIT. So for this one, we take the gross profit minus fixed cost, which is stated in the question, and then minus depreciation. Depreciation is also here. I already calculated this one. And then we get the EBIT, which is 5.4. This is the revenue. Sorry, before interest and also tax. Next one, we wanna calculate the tax. So the tax here stated in the question is 40%, the tax rate. So 5.4 mil times 40%, which is 2.160. So the EBIT minus tax, we got 3.240 million. And for the operating cash flow, it's easy, just net income plus depreciation. So we got the operating cash flow for each year is 5,440,000. The next one, we want to build the cash flow timeline. So the year 0, this is the, what is that? We call it, it is the increments of like, oh, this is one, the plant and equipment, which is the one-time cost that the company should give to start the production. So minus because they spend money. So this is minus 15.4 million. And this is the extra money needed to run the project. So this one, we have to give back to in the last year, so in the 7th year. So this is the total initial investment, 16.3 mil. And this is the operating cash flow, which is this one, 5.5 million 440 per year. And in the last year, in the 7th year, we add back the 900,000. So I already make this cash flow timeline on the Excel. So this one, this one, we use just a simple formula, right? Here, 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 here. Yeah, just like that. Okay. That's for the cash flow timeline. Here, the same. Next one is we want to calculate the payback period, because 3 main thing that the question 1 is the payback period, the NPV, and also the IRR, or wait, yes, the IRR. Okay, this is that we want to calculate the payback period. So in the first year, okay, I just give you this one. Okay, this one, because in the first year we have 16.3 the money that we spend, and then in the first year we get this one, 5.4. So in the second year, our like, what you call it, they still need 10 million to get to 0, right? So in the second year, they got another 5.4 mil, this one. And then in the third year, they only need 5,420,000, right? Then same one is in the third year, they got the same money with the last year, and in the fourth year they already got profit. Okay, so how long they need to get the payback period, to get the payback, which is 2.996 years, and we round it to 3 years. So around 3 years to get the payback, or to get the profit from the initial investment. And next we're gonna do the NPV, or net present value. So this is the formula for NPV. We use this one, right? We use the cash flow timeline. So here I already do it. And after we got all the present value, we add all of them. So I got the total of 20,678,052. We minus by this one. We minus by total initial investment. So this is the money that this is the net present value that we got, and then we minus them. This is the present value that we got, and we minus them by the initial investment. Then we got this one for the net present value. Next one, or last one, we wanna do the internal rate of return. So this one we have to like trial and error, but you can do it from Excel. So I already did from Excel. This one, IRR, or initial rate of return. For the formula is this one. You can copy it if you want. IRR, and you put all the cash flow timeline here. And we got 27.59%, which is higher than the than they asked, which is 14%, right? So if you wanna make sure it is all right or not, it's the IRR all right or not, we can reverse calculate. So we just put the 27.59 here into the NPV formula. So I already did this one. So we got all the present value, and the total present value is 16.3, which is the NPV is equal to 0. So yeah, one of the requirement to that the IRR is good is that they have to get the NPV to 0. Okay, that's all from me. So I will write all the answer here. So the first one, payback, right? Payback period is, we got here which one? Payback period. Okay, this one. Then for the NPV, this one. Okay, we just put the answer. There you go. And the IRR. internal rate of return. We got here 27.59%. So yeah, I will recommend you to do the IRR on the Excel because it will be easier for you rather than you do trial and error. So yeah, I think that's all from me for the case 4. Hope this helped you. Assalamualaikum warahmatullahi wabarakatuh.